Bismillahirrahmanirrahim. Today we are going to speak about the numerical solution of first order differential equation using the Runge-Kutta method for fourth order. This is the numerical technique to find the approximate value for functions or some functions given by differential equation. So this method, the Runge-Kutta method, the definition, is just approximation or just is a method to approximate the value of the function given by the differential equation. Or just by the differential equation. Capital F x y prime or x y and y prime x y y prime equal to 0, where the desired approximation is given by y plus 1 equal to y sub I plus 1 over 6 multiplied by k1 plus 2 k2 plus 2 k3 plus k4, where k1 is given by h multiplied by f of x I y I. It will be the step will be given in the problem. K2 is h multiplied by f xi plus h divided by 2 yi plus k1 divided by 2 k3. So we are using the previous values to find the second approximation or second values of k. That will be h multiplied by f xi plus h divided by 2 and yi plus k2 divided by 2, and k4 is equal to h multiplied by f of xi plus h yi plus k3. And that's why this is called the fourth order Runge-Kutta method, because we have to find 4 approximations or 4 values. Then we're going to use these 4 values to find the needed approximation. And we have to notice one thing, that for the k4, you see that k2 is xi plus h divided by 2, yi plus k I divided by 2. K3 it is h or xi plus h divided by 2 and yi plus k2 divided by 2. But for k4, it is not divided by 2. It is xi plus h and yi plus k3. This is the Runge-Kutta method to find approximation for some given value or for the first differential equation. Sometimes also it is used to find second order differential equation, to find the approximation for the second order differential equation. Let's have one example to explain the idea. Let's use Runge-Kutta method. Fourth order. To find the approximate value y of 0.2 up to 4 decimal places. For the initial value problem. Given by y prime plus x y equal to 0, and the initial condition is y sub 0 of 0 is equal to 1, where the h, the step given there is 0.2. So I need to find the approximate value, which is y 0.2. I have y, we need to find y 0.2, and given that h equal to 0.2, there's a relation between h and what was given there. Since we started with x sub 0, it's given there, x sub 0 is equal to 1, to this one. So it is equal to 0, and y sub 0 equal to 1, these values. So this will be my first value for the first iteration. Because the Runge-Kutta method is like an iteration or iterated method to find consecutive or the value for y using the regression given there, y sub I equal to y I plus. So we are using the previous value to find the next one. And this process can be repeated again and again. So in our first step, we are given that x sub 0 equal to 0 is given in the problem, and y sub 0 is equal to 1. These are given. H equal to 0.2. Now y sub 0 or y of 0.2, it is like that we are moving from 0 to 0.2, the value there, and we need to find the value at this point. So we are moving only one step. We can call it just one step. Or I will say it is one iteration. From 0 to 0.2 with h equal to 0.2 is only one step. So I need only the first iteration, y sub y. So this is y sub 0 is given equal to 1, and we need to find y sub 1. That's at the value of 0.2, when x equal to 0.2. So using the Runge-Kutta now, we need to find k1, k2, k3, and k4. k1 given by h f of x, y. Now, what is my function? What is f of x, y? We have y prime plus xy equal to 0. So y prime is equal to minus xy. This is my function f of xy. To this one. So f of xy equal to minus xy. Move it to the other side. So y prime equal to minus xy. So my function is f of xy equal to minus xy. F of xy is given by minus xy. Now I can find k1. So k1 is equal to h, which is 0.2 multiplied by minus x sub 0 y sub 0. We have to substitute x by 0 and y by 1. So this is equal to minus 0.2 multiplied by x sub 0 is equal to 0 multiplied by y1, which is equal to 0. So k1 is equal to 0. Use it to find k2. k2 is equal to h multiplied by f of x0 plus h divided by 2 y sub 0 plus k1 divided by 2, which is equal to 0.2 multiplied. I have negative. I will write this negative outside, so this is minus 0.2 multiplied by x0 is 0 plus h is 0.2 divided by 2 multiplied by y. What this is given by y0. y0 is 1 plus k1 is 0 divided by 2. So it is minus 0.2 multiplied by 0.1. This is minus 0.2 multiplied by 0.1 multiplied by 1, which is equal to minus 0.02. So this is k2. Now let's find k3. k3 is h multiplied by f of x0 plus h divided by 2 y0 plus k2 divided by 2. So it is minus from the function multiplied by h, which is 0.2 multiplied by 1. I'm sorry, it is 0 plus 0.01, because h divided by 2, 0.02 divided by 2 equal to 0.1 multiplied by y0 is given is equal to 1 plus or minus k2 0.02 divided by 2, which is equal to is minus 0.2 multiplied by 0.1 multiplied by 1 minus 0.01. That will be 0.9, which is equal to this minus 0.9 multiplied by 0.1 multiplied by 0.02. That's equal to minus 0.0018. So this is k3. Next one, we need to find k4. k4 is equal to h multiplied by f multiplied by x, or f of x sub 0 plus h this time, and y plus y0 plus k3. Now we need to divide by 2 for the last step. So this is minus 0.2. Again, this minus from the function. It is not from h. 0.2 multiplied by 0 plus 0.2 multiplied by y0 is equal to 1 minus 0.0018. This will give me minus 0.04 multiplied by 1 minus 0.0018 is equal to 0.9982 multiplied by 0.04, or negative, it will be minus 0.039928. 28 or TZT, because we need it just up to 4 decimal places. Now I have K1, K2, K3, and K4. We can find Y sub 0. And Y, or sub 1. Y of 0.2, it is the first iteration, because as I said that it is equal to 0.2. So to move from 0 to 0.2, it is one step. So it is Y1, which is equal to Y sub 0 plus 1 over 6 multiplied by K1 plus 2, K2 plus 2, K3 plus K4. They're up in the formula to this one. Now just plug these values to find Y sub 1, which is equal to 1 plus 1 over 6. Sum of this is 0 plus 2 multiplied by K2. K2 was given by minus 0.02 plus 2 multiplied by K3, which is minus 0.0018 plus K4, which is minus 0.03993, which is equal to, I will have 0 plus, or say minus 2 multiplied by that is 0 again, minus 2 multiplied by 0.02 minus 2 multiplied by 0.0018 minus 0.003993 divided by 6 plus 1 is equal to 0.9860 or 61. Y of 0.2 is approximately equal to 0.9. You can say this is approximation. It is approximated by 0.9861. So this is the idea of the Runge-Kutta method. First order means we need to find 4 estimations or 4 approximations. Then we find the sum of them using the given formula. Now this part, it is like the weighted average. I have K1, it is 1 plus 2 plus 2 plus 1, it is 6. And that's why we are divided by 6. We are finding the weighted average for these values. 1 over 6 equal to K1 plus 2, K2 plus 2, K3 plus K4. This is the average of these approximations. Plus Y sub 0, and we will get the needed value.